Last one! Welcome back to the Punny Math Teacher. We are working on our systems. So we are going to keep this under 15 minutes because all of them have been under 15 minutes. So yes, it should take you less than 30 minutes, however minusculely, less than 30 minutes to finish this notes. And there's only 2 examples, so we should be really golden on this. And make sure you pause, take your time. And it's not going to be a rush. That's not my goal. My goal is to rush so that you can put the wait time on you and take as long as you need, because our expectation is to use twice the video's length. Make sure you're pausing, rewatching, change playback speed. I know I talk really fast, so you can always make me sound really slow if you want. 1.25 and 1.5 speed, I guess that's faster. So 0.75 wouldn't be as big of a deal if you wanted it slower. Okay. And objective, we're going to be using graphing, substitution, elimination. We're now on inequalities for our system. So instead of equations, we're going to see some less than and greater than symbols. And we're actually going to be using graphing as our main way of doing this. It gets funky if you do substitution or elimination just because nothing is equal to anything else. It could be equal if it's less than or equal, but with a strict inequality where it's just less than or a strict where it's just greater than, you can't really replace things because they aren't equal. So there's that stuff. So graphing works best for inequalities. The table of contents. Boom, there you go. Solve a system of inequalities. We're on page 39. So let's scroll to page 39. There we go. Okay, so I'm just going to put some quick notes at the top as a refresher. So remember that we draw solid lines when we have the equal to option, because that means the line is actually part of our solution. They are equal. And then if the line is not part of our solution, then it is dashed when it's these two, and we'll put a comma in between, when it's just the strict inequalities of less than or greater than. And I'm going to put some stars up here because I want to make sure you remember this part of information and that we shade where it's true. Okay, so these are the 3 highlights of graphing inequalities, but if you want to give yourself a better refresher, go back to, there it is, 2 variable linear inequalities, page 31. Okay, so we're going to do 2 examples. Our first one is y is less than negative 1/3 x plus 3, y is greater than 2x minus 4. Draw your axes, have room for the testing, and I am going to write the next one down as well so you have all your room already allocated to our questions. Y is greater than or equal to negative 4/3 x plus 2. Y is greater than negative 4/3 x plus 5. So these are going to show 2 different strange, not really strange, situations that you could get yourself into with inequalities. And then also, if you have highlighters, this is a great thing to do because we're graphing 2 inequalities, or you're shading, on the same graph. So if you want to overlap them, it's nice. And my blue highlighter doesn't exist over here, so I only have yellow and green. It's fun if it's blue and yellow because then it makes green where they overlap, and it's fun to do like blue and pink because it makes purple. But I don't have that. I have green and yellow. So we're going to graph our first one. Notice that both of these will be a dashed line because if I put any solution into here, it's not actually going to be a solution or coordinate. So if I put 0, 3 for the y-intercept, that is not going to be a valid solution because 3 is not less than 3. So I'm going to 1, 2, 3, 4, 5. I'm going to make my scale actually. I'm going to do that on both of them. Okay. And instead of 5 check marks on each axis. So I'm going to go up 3. From here, I'm going to go down 1 and then run 3. It's a dashed line, so when you use your straight edge, make sure you're dashing it. Dashing all the way. Okay. And those are pretty long dashes, but it's dashed, you get the idea. And then I'm going to graph both of these, and then we'll test them both separately. That way I don't have to mess up with my lines. Okay, I'm going to go down 4, go up 2, run 1, and you can make this more precise if you want by making more points on your line. Oh, my markers are getting in the way. Okay. And remember, it's a dashed line. Okay, so I'm now going to test for each of these. I'm going to make this first one have a key of yellow as its solution and green as its solution, which then would mean the overlap will be their solution. And if you want to make a key of that, you can as well, and say this and this equals solution. Who knew the green would overpower the yellow that much? Wow. Okay, so I'm going to test a point that is not on this line. I already know that this line is not part of the solution, so now I need to test the areas around that line. The line is a boundary for. So for this first line, I'm going to test 0, 0 because it's not on the line. And why not? So if you want to further test or make better keys of just how your work looks, I'll use these as my key. So for my first one, I'm going to test 0, 0 because it's not on the line. 0 goes for my y, less than negative 1/3 times 0 plus 3. Notice how I'm substituting in with a parentheses. You could do that on the left-hand side, but there's nothing over there, so it's fine to not have it. 0 is less than 3. True or false? That is true. That means everything below this line is true. So I'm going to shade it with my yellow highlighter. That is not flush. And then for this line, 0, 0 is also not on it. So I'm going to have 0, 0. 0 is greater than 2 times 0 minus 4. 0 is greater than negative 4. That is true. 0 is larger than a negative value. So that means everything over here towards that 0, 0 is going to be shaded. Okay, and then if you wanted to make it more precise, you could just shade in pen that is my solution area. So any coordinate in this area is going to be a solution to this system. Okay, the green area will be a solution to only the second inequality, and the yellow area is only a solution to the first inequality, but where they overlap will be a solution to both. And notice that it's being bounded by the two lines, but these boundaries are not part of the solution because they are not solid lines. So, woohoo! All right, on to example 2. So example 2, I'm going to go up 2, down 1, 2, 3, 4, run 1, 2, 3. And I'll do both points at the same time. Why not? Go 1, 2, 3, 4, 5. Now go down 1, 2, 3, 4, 1, 2, 3. And the top one that has a y-intercept of 2 is going to be a solid line. And then the second one is going to be a dashed line. Okay. So those are what my lines look like, and now I'm going to test them. 0, 0 is not on any of those lines, but I am going to test different points just so you can see different testings. I can also draw a line to that key, that they're the same. I'll use this one for yellow. I'll use this one for green. Okay, so for this greater than or equal to, let's test negative 1, positive 1. Negative 1, positive 1. I guess I should also label my work for testing. Okay, so negative 1, positive 1. Positive 1 greater than or equal to negative 4/3, negative 1 plus 2. That makes positive. So 4/3 plus 2. I don't even need to know what that is, because is 1 greater than 4/3 plus 2? No, 1's not even greater than 2. So this is going to be false, which means everything here is going to be false. So it's going to be everything greater than it. Okay. And then for my green, what if I tested 5, 1? Okay, so if I test 5, 1, 1 goes for my y, 5 plus 5. Okay, This is 15 over 3 if I want to make a common denominator. Wait, I'm just multiplying. Doesn't actually matter. Oh well. I'll simplify that back down to 5. So that's negative 20/3 plus 5. Negative 21 over 3 is negative 7. So this is negative 6 2/3 plus 5. Is 1 greater than whatever negative 6 2/3 plus 5 is? Yes, because this is still going to be a negative number because this negative 6 2/3 is larger than 5. Like the absolute value of it, the distance from 0 is greater than 5. So it's still going to be a negative number. So 1 will be greater than that. So it's actually true, which means that I'm going to shade all of it above it. Woo! And I'll just shade it with my pen. So notice that this solid line is not any part of the solution because it's not with that green area as well. The green, it's only bounded by this dashed line and then the green, yellow, and blue pen. So even though I drew parallel lines, which typically in graphing doesn't give us a solution because they're not intersecting, but these shaded areas do intersect. So even though they're parallel lines, they actually do give us a solution. So many of them, because every single point in this area is a solution. So yay, we did a system. We did a system. And there's your comprehension questions. Is the same as before. So overall, which method is the best for finding solutions to a system of inequalities and to a system of equations? Which would you prefer? So, all right. Have a great day and thank you for watching. Bye.